focused on what we're doing, take decent notes, ask questions if you're not sure about something. Okay, good news, we won't make any graphs today. There's a little bad news, but I'll just kind of keep it to myself, okay? All right, I'm going to start, because once I start, then the announcements will begin. That's something we're going to take steps, okay? Your graph should look kind of like mine. Now, some of you learned the hard way. I did not give you an X and Y axis. You had to put them in. You should have put them in a place that made sense. I know without looking at your homework yet, some of you probably put it here, and you're like, oh, this didn't work out super well, okay? So you should always look at your lines and then decide if you're going to put them in. But I'm going to breeze through the graphing because you have to know how to graph lines. You're either graphing it out of slope-intercept form, or if I give it to you in standard form, I said it yesterday, I'll say it again, I don't care if you want to do intercepts or convert it. It doesn't matter. It's the same line. We got to get it, okay? Last comment before we do announcements. IMS, you only graph the line once. You don't have to graph an extra thick line. We're really just going to focus on this question after the announcements.
The 4:15 activity buses will continue. Attention math count members. Today's math test meeting has been canceled. Please take your regular bus home. Tomorrow is Autumn Dance in the Bird Circle, where black and gold meets pumpkins and flies. The festival will be from 5 p.m. to 6:30 p.m. Student tickets can be purchased on school days. Tickets will also be available for free purchase at the school during school lunch today for $50 cash or a check to the DMS PTO. Students of purchase tickets will automatically be entered in a raffle for prizes. Tomorrow is the annual DMS Turkey Trot. Students that would like to participate can still donate online by midnight tonight or bring their money tomorrow morning. We would love to have a 100% participation. Remember, all money raised benefits local families in need. There will be a PLA meeting from all interested students on Tuesday, October 28th, at the DMS LGI room from 7:40 a.m. to 8 a.m. To discuss more details next week.
You should be opened up to this question, by the way. It's just some of you were there and some of you were...
15 a.m. and you can make it early. The DMS football team ended their season with another big win. Scoring was no problem for the Foxers offense. Gino Jones had 3 touchdowns, while Jimmy Hastings and Charles Gordon scored 2 touchdowns each. Keydon Morris, Drew Ionati, Marco Costello, and Keegan McKee all forced more points onto the board as DMS offense could not be stopped. Great defense was set up as Luke Monterer getting 2 turnovers. The final score of the game was 46-6. Congratulations to the DMS football team for capping off a great season with another win. Tomorrow is the DMS Turkey Trot, so wear orange, yellow, and brown. Will the following students please report to the office at the end of the period? Tyler Madden, Austin Wilson, Anna Basin, Olivia Etcher, Addison Ford, Jade Steele, Catherine Stone. Have a great day, DMS.
Okay, so I want to talk about this question, number 7. I'm not asking for you to get it wrong. I just want honor system. Did anybody have a hard time with it or get an answer that didn't make sense to number 7? Oh, cool. I kind of anticipated that. Good news, I think I know what your problem very likely was. 5 years from now, a father's age will be 3 times his son's age. And 5 years ago, he was 7 times as old as his son was at that time. Okay, the reason these are tricky is one missing thing, it all falls apart. This is a reason that we are going to be spending more time on systems. We have to work word problems. Okay, we have to work good ones, and this is an example of a good one. It always starts by declaring your variables. They always tell you pretty much in the last sentence what you should be looking for. So you're not just looking for the father's age, you want to be more specific. Okay, I just put my calculator. Thank you. We want specifically what? Father's age now, son's age now. So if you're not a big word problem person, you can get better at them. They typically tell you at the very end, here's what you're looking for, okay? Each sentence becomes an equation, but you got to read it carefully. 5 years from now, a father's age will be 3 times his son's age. So if X is the father's age now, what would it be in 5 years? Here's where I think some of you probably fell apart. And by the way, this happens every year. What's going to happen in 5 years? He's going to be 3 times his son's age. So if y is his son's age now, I'll bet some of you wrote this. Have a conversation with somebody about what is it missing, what is wrong, and how are we going to fix it. Okay. Why is it wrong? How would you explain to somebody why it's wrong? Don't tell me what it needs yet. Why is it wrong? Can anybody tell me? It is wrong. Eliza. Well, that's just telling me what's missing mathematically. Tell me why this doesn't match the situation, I guess. Anna.
It's saying the son's age now, not the son's age in 5 years.
That's what they're multiplying by 3. The way that this reads, the father in 5 years is equal to 3 times the son's age now, plus 5. Is that right? No, it's 3 times the son's age when? In 5 years. If I put parentheses around y plus 5, and by the way, some of you you'll get this. Some of you won't pay attention and you'll just get owned on this question when you see it on a test. The parentheses are all you need to fix it, but they make a huge difference. Now the problem reads correctly. The father in 5 years is equal to 3 times, what does this represent? The son in 5 years. That matches it. If you solved it without the parentheses, you probably got terrible answers. Are they negative? Yeah, they're negative. I think they're really far off if you don't have the parentheses. That's why. So let's write the second. This is not enough information to solve the problem. Now we write the second one. Okay? 5 years ago. So what is dad 5 years ago? X. He was 7 times his son's age. I need the parentheses again. But what's this going to be? Perfect. This leads to the correct answer. Okay? Now, if that was all you were missing, you'll get there. You'll be fine. But they do matter quite a bit. Okay? The answers are 40 and 10. They actually do work. Okay? You can actually check it pretty quickly. Okay? Because if it's 40 and 10, in 5 years, how old's dad? How old's the son? That's times 3. And 5 years ago, how old was dad? 35? Son was? That's times 7. So they do check, okay? So if you had a hard time with it, you probably were missing the parentheses. You need to know why, okay? I don't really care about the rest of it. Okay, let's go to 6-2. 6-2 is actually pretty critical. We're going to actually use Jimfa's method today, but I got bad news for you. It's not actually called Jimfa's method. Yeah, you can't write Jimfa's method and have anybody besides me know what you're talking about. And more bad news. Jimfa's method was too easy. We're going to use it, but we're going to use it a lot more involved. It's called substitution. I think a lot of you will actually like substitution, but you got to give it a chance. I don't really care about these warm-ups, okay? Let's quickly put these solving for y. We can roll through this together. What would you do first to solve that for y? Let's all say it out. Add 2x to each side. So 5y is 2x plus 20. And then you would divide everybody by 5. So what is y? Good. Now up until this point, myself and Miss James, we've been making you convert. And for most of the time, you probably are like, why are we bothering with this? You will know why today. Why the converting is so important. We're not just doing it to kill time. There's other things we could be doing. What do you want to do first on this one? We have to solve it for y. I want to multiply by 12 first. You don't have to, but I think it's a really good idea. You could just do 4. Couldn't you? Let's just do 4. We have options. So it's 4/3 x minus what, y? No. Don't forget to multiply the 12 by 4 equals 48. Should be right. Now here's why you have to be spot on with your equations. I can't have you goofing up the pre-algebra stuff. It's just a little shuffle. Add the y over and what? Subtract the 48. So what is y? Y is 4/3 x. Good. Now there's other ways to get it. We could have multiplied by 12. Why bother? Okay? And then the last one, old school. I would distribute. Anybody else? Yeah, old school. So -8 plus 4y plus 4x equals -6x minus 12. I want y by itself. So I got to get some of this other trash to the other side. I can subtract 4x. I could also, what, add 8? I'll let you do two things at once. I won't run this change. Just don't get it wrong. So if I subtract 4x, negative 6x becomes what, negative 10x? And if I add 8, that becomes, that minus 4?
Yeah.
Divide everybody by 4. Y is negative 5 has x minus 1. We did it, okay? So your converting has come a very long way. I feel good about it. You should feel better about it than you did walking into my class like a couple of months ago. The question is, okay, why are we doing this other than the teachers making us? And that's because of substitution, okay? Yes, we get fake literacy again. Man, my fake literacy is getting to be pretty good, actually.
Yesterday in social studies we had fake literacy, but it was the
Look what we had in social studies today. We're going to use the appropriate form of the word substitution. Today we had a... I know what you would all just say. You would say so. Substitute teacher in social studies class today. The coach. He made a substitution because the player threw the ball out of bounds and said, my bad. And I said, no kidding. It wasn't my fault. It was your fault. You threw it out of bounds. Substitution. And to evaluate the expression x plus 6, you can substitute, okay? Cool. So, I know a lot of you love elimination. I actually think some of you will really like substitution as well, because you're basically going to take algebra and turn it into pre-algebra. You are good at that, okay? So we are going to continue to look at this method. This is called substitution, okay? And I want you to look at what it looks like. Here's an example. Given that system, that wasn't even close to a circle. This was a box. Given that system, right now we have 3 ways to solve it. We could graph it, no thanks. We could use elimination, but it's not in standard form. Or we're going to use our new method of substitution. And if y equals 3x, then what that means is anywhere where there's a y, I can replace it with, guess what? 3x. Okay, this is direct substitution. So what we're going to do is we're going to take this 3x and we're going to plug it in for y right there. And then all of a sudden, an equation with 2 variables is now down to 1. You can only solve for 1 variable at a time. Boom, we get x equals negative 8, and then we can plug back in and then get y. Okay, so this is actually classic substitution. Okay, what I mean by that is we have y equal to 3x. We swap it in here, and then we're good to go. We're taking an equation with 2 variables, and we're getting it down to 1 and then solving. Okay? Now, here's why GMFA's was considered substitution. It's not really great substitution. If you recall, GMFA's method, it was solve each of them for y and then set them. But what he was doing was he was basically substituting this into that. But we're not going to do it that way. We're going to actually approach it a little bit more directly. Okay, but let's do this one. So I'm going to substitute x minus 1 in for y up here. So what is it? X minus 1 equals 2x plus 7. Somebody probably already has x.
Yep. Negative 8.
Oh, then what's y?
Negative 9.
Good. How'd you get it so fast?
Because I was working at
Well, that's a bad answer. How do you get it? How do you count? You can. Sadie, who raised her hand. How about that? How could you get it so fast?
Negative 8 minus
Sadie, who raised her hand.
X minus 1 is negative 8.
Plugged it into here, and then you get negative 9. Okay? You will never get ones like this on a test. Too easy, child's play. Even this next one's a little bit too easy. Okay? So GMFA would have said, solve this for y, then set them equal to each other. We're going to skip that. Okay? If y is equal to 3x, what did we just learn? We can take this 3x and plug it in where? The other equation. So the top equation now becomes what, everybody? X plus equals 8. 4x equals 8. Boom, x is 2. Quick, what's y?
6.
Good. Good. These are, again, still too easy to give on an exam. This is actual substitution. GMFA's is like you get them all set and then substitute one for the other. We're going more classical substitution, okay? Couple more together. So if I go this next one, I'm not going to bother solving them for x or y. The bottom one's actually already solved for y. So who can raise their hand and tell me what am I plugging in where? Charlie.
2x plus 2 then in parentheses.
Yeah, I want you to tell me the words. We're going to plug in x plus 3 in for
The y.
in the top equation. Do not plug it into itself. It will never, ever, ever work. Okay, now he already gave it away. You learned last year from Miss James. This is not just a Miss James thing. This is a math thing. When you plug in the x plus 3, guess what it needs to go in? Parentheses. Sometimes Miss James just tells you things she likes and it's her preference. Sometimes she tells you the truth, and she's telling you the truth. You got to put it in parentheses. Can you solve this? Gosh, I hope so. Distribute. Combine like terms. I got 4x is 32. Ooh. X? 8. Y?
11.
Good. Use this one right here. Okay? Moving along. What can I plug in where? On this next one. You can raise your hand and tell me what plugs in Matthew where?
Or negative 2x plus 6 can plug in
For what?
for x.
No. What's it equal to? It's equal to y. In the second equation. So what does this bottom equation become, everybody? 3 times, in parentheses, negative 2x plus 6, keep going, minus x plus 3 is 0. We're taking something with 2 variables and we're knocking it down to 1. The substitution gets you down to 1 variable. And I know you can solve the 1 variable equations, because if you couldn't, you're not sitting in this class. Distribute. You combine like terms. Anybody get x? It's 3. Should be regular 3.
Oh, yeah.
No way, I'm going to talk about that. So what's y? Good. Now, here's the good news about this next test. I said it. They all check. So let's say you thought it was negative 3. And like Matthew, you're not the only one that's going to think it's negative 3. If you plug it back in, it's not going to work. So then you can quickly check your work and then get a sense of it. Okay? But this is substitution. Okay? And it actually is more efficient than even elimination at times. Okay? Now sometimes we have a little bit more work to do. Okay? But I want you to try the next 2. Just the next 2 with somebody else near you. Maybe talk about like what you're going to do. See if you can efficiently make it.
Put in number 5.
Keep in mind, they check. So there shouldn't be like any kind of debates.
Oh my god. Yes, I can. I'll see if I can get that in my home base. Yes, I know.
Come on, come on. Don't get sidetracked here.
I got 31.
I got 31 Y's and I got 31 O and
Yeah, we all got 31 fours. I think Jude is wrong. Either Jude is wrong. Either Jude is wrong or we're all done. Yay, he's wrong. Brother. Bro, Isaac, can you get that? Nothing in 5 seconds.
iPad off. I don't know how to log his iPad.
He gave me consent.
I don't give a single
Can we watch what we're saying? And not do this thing? Yeah, let's try it. Because remember, you're my closest table just getting broken. I can't always have you on task. It's got to get fixed. Okay, your first one. Now you can leave them fractions if you want, or you can. The decimals are okay, but it's 31/4, comma, -1/8, or 7.75, -0.125. How did we do with that one? You have the calculator, so if you're really not sure how to plug in 31/4, use it. If I didn't want you to have it, I wouldn't let you have it, but you can. Okay, but that's how that one's done. Okay, we'll show this one, then we'll talk about the fun ones, because the fun ones are coming next. Yeah.
You should put some like handouts to you. You have to make those features.
This one's a lot prettier. Hey, for the last one on that page, I got x is 3. Hey, you too. I got x is 3. Anybody confident? You want to raise your hand and tell me what y is? Anybody? Theo? What? Y is 5. Okay. Now, you got to tell me how those ones look. If those ones don't look okay, the other ones won't at all. But the gist is, we're plugging in, and we're taking an equation with 2 variables down to 1, and we're taking algebra, we're turning it into pre-algebra. Like, the only new thing today is me showing you this from here in pre-algebra times. Okay, and you mastered pre-algebra. You had to. Okay, just don't forget to plug in and get the other variable. Okay, now why were all of those decent? It was ready to go. Plug and play. One of them was already solved for y. That's not always the case. So if you go to the next page, we can skip past the notes. You can look at them if you need to. What do you notice about this one? Nobody is solved. Nobody is x equals or y equals. So you have to solve one of them. Now there's a really, really smart choice for what you should do. Can you be more specific? The bottom one for x. So your options are solve the top equation for y. How do you sound? How's that sound? Okay. Solve the top equation for x. No. Solve the bottom equation for y. Solve it for x. Yes. That's, so we're going to shuffle it around. What does that become? X equals? Oh, -3y minus 7, or -7 minus 3y. You understand why I can't have you shuffling these equations around incorrectly at this point. You got to be really careful. Okay. Now, where is that going to go? That whole term, -3y minus 7, it's going to go in for x in which equation? The top one. Do not plug it into itself. I can tell you what will happen. You won't get an answer. You won't get an answer. Okay. So 6y plus 5 times -3y minus 7. And then it's just pre-algebra from here. So -15y. Now watch your distributing. Some of you go way back a couple weeks. Your distributing was a little wonky. So that's -9y is 43. Gross but accurate. I got y to be a -43rd. 9ths, or -43/9. Now, thank goodness you have the calculator at this point. But I'm also here to help you and save you. I have to plug back in to get x. I want you to say yay when I point to the equation we should use. No, don't say anything. Just say yay when I point to the one you should use. Now, you can use this one if you want. This one's already solved for x. Why? Just use this one. Use this one. Okay. I'll gift you this one. I think it's gross again. It's like 22/3. 22/3. I don't like mixed numbers. Okay. Can we grow up here? Okay. 22/3. I mean 7 1/3 is fine. -40/39. So before you try these next couple, these were not ready to go. This one was not ready to go. You had to solve it for a variable, then plug it in. That's why I've been making you convert, so that you can plug in. So try the next two in that row together. They're a little bit cleaner. Try those ones together. Decide what should we solve for, and then where is it going. Julie, what are we doing? Come on. Come on.
You solve this for.
We're solving for depression.
Oh yeah, the top one.
We're solving
I'm sick of this like poltergeist thing that's going on up here.
What's
It's like
happening?
poltergeist.
What's happening?
Not talking to you. Go. Talking to myself. Like I do most days here. I'm ordering a replacement piece. Does anybody need anything from Amazon while I order this piece?
Yes.
Okay.
I need donuts.
Can you order me 40 pounds?
No, I'm not ordering 40 pounds of anything.
you won't be getting your 40 pounds either right now.
No, it's not even your email.
Focus, come on.
I need 40 pounds of rice cones. Search it up. It's cheap.
X equals
It's going to be
negative
about
one.
$5,000.
No, it's not.
Did you get negative one?
No, $11. $11.95 the tractor's for 40 pounds. That's the milk.
I do not believe the 6 that we
He said it. He said it.
Can I see thumbs up, thumbs down for negative 11, negative 19?
Yay.
Good times.
I forgot to buy
Second one's a little goofy.
I forgot to buy my mom.
I forgot to drop this.
Actually, cook something that always. Yeah.
I ain't that level.
What did you do?
Someone asked.
Boy, they really love 3 on this page, don't they?
The lucky the automatic.
Second page down below.
14 guys.
Oh, really? Oh, really? I thought it was 6. Guy asked me. No.
Okay, now, the last in that row. I actually think it's tricky. If you're finishing it, that's cool, but I'm going to start looking at it. I definitely want nothing to do with the bottom equation. I mean, I guess you could solve it for x, but I don't know. That's not really my style. What I'm looking for are coefficients of 1 or negative 1. I see it up here. And again, this is why I need you to be able to shuffle the equations around. I don't know why you're worst time to start talking. Okay. What I did was I added this x over. I subtracted 5. I subtracted 2y. X equals 2y minus 5. I know you can handle that kind of equation shuffling. You kind of have to be able to. And then where is this going? 2y minus 5 is going into x right here. Okay, then you distribute. We're not going to relearn this stuff. There's more than from here. There's more than enough people that know how to solve this one variable equation. So you're not going to get a reteaching on this part. This part we will work on. But that's what I did. I got y to be 3. Anybody get the x that goes with it? This one. Good. Okay. Choices. You have to make wise choices. Okay. You could have solved this bottom equation for x. Did anybody do that? You could have. I wouldn't. I would make it simple. Keep it simple on yourself. Okay. Okay. Now moving ahead. One of the other focal points of this entire unit is word problems. We need to build them out. We're going to do some basic ones every day, and then a day next week, I got some tricky ones for you. Okay, but you're going to help me. Okay, a snack bar sells 2 sizes of snack packs. I used to love these. Okay, Okay, the pudding snack packs, do they still have these things once it comes back?
Yeah.
They may like the butterscotch flavor.
Yes.
I love butterscotch. Okay? A large snack pack is $5. A small pack is $3. In a day, the snack bar sells 60 of them for a total of $2.20. We've been doing this stuff like every day, but we still want to get it right. So let's use X and Y. What could X represent?
L.
Can't just say L. A large snack pack, we could abbreviate that SP. What's Y? Okay, let's see who's been paying attention the last week and a half. Who can give me both equations for this? Okay, Clint. Look at that. Okay, cool. Now, if I told you to solve this any way you wanted, who would draft it? Good job. No hands. Who would use elimination? I bet a lot of you would. Okay, I probably would as well. Could we use today's method?
Yes.
Yeah, so let's just practice with it. I'm going to solve the bottom equation for, it doesn't matter, X or Y, just say one. I heard Y. Some people said Wex. I did, I heard a
That
Wex.
was me.
Okay, I did hear it. Y equals 60 minus X. Where's this 60 minus X going? Right there. Okay. You can solve it. You don't have to wait for me to get the weather screen past here. So 5X plus 3 times parentheses. 60 minus X is 220. 5X plus, we distribute. 180 minus 3X is 220. I don't feel like most of you would use this method. I feel like most of you would probably use elimination. Which is fine, but we're just practicing with it. Okay? I got X to be 20. Quick, what's Y? 40. Good. You're supposed to look at that problem and be like, we've written problems like that for like a week now. Just stay tuned. Okay, to the next one. A school is planning a field trip for 142 people. The trip will use 6 drivers, 2 types of vehicles, buses and vans. I mean, those are my variables already. So X is the number of buses. Y is number of vans. I can tell. A bus can seat 51 passengers. A van can seat 10. We're going to do the same thing. Both equations to match this situation. Liza. Now the 51 like spooks people because it's a weird number. It's not that weird, it's divisible by 3. 51 people per bus plus 10 people per van, 142, bada bing, bada boom. Okay, cool. We could solve it, but we're just going to plow ahead because I want to get to other problems. Okay, and the last one, the measure of one acute angle. Ooh, you should know this. What's acute mean? Raise your hand, raise your hand, raise your hand. Nora?
Less than 90 degrees.
Okay, so if this was a right triangle, which they tell us it is, then an acute angle has got to be one of the smaller angles, not 90. Bigger than that would be obtuse. Okay, the measure of one acute angle in a right triangle is 4 times the measure of the other angle. We're going to write a system. So if X is the first angle, then Y is the second angle. The measure of one acute angle is 4 times the measure of the other acute angle. Any thoughts? Delphina? I can't hear a word you're saying. So Y equals 4X because the one is 4 times the other. This one's kind of sneaky. Well, close. Not 4X plus Y, just. The angles have to add up to 90 because you should know all triangles add up to, I heard it, 180. So if this is X and this is Y, 90 is already taken. So X plus Y is equal to 90. I would totally use substitution on this one. It's ready to go. I would throw this in right there. Okay, cool. I don't care about solving them though. You're gonna see a lot more word problems over the next several days. They'll get more involved than that. You can finish those too if you're interested, but one word substitution. The last thing that we need to consider, because this pops up every single day. How do we know if there's no solution or IMS? Simple. If you look at this particular example, if I substitute in, I plug negative 2y plus 4 in for this x. I do all my wonderful algebra stuff. All the variables wash away. What am I left with? A true statement. That doesn't mean there's no answer. That actually means IMS. What do you think no solution is going to look like? I heard the correct term, a contradiction. You plug in, you do all your little algebra stuff. It's wonderful. You get a contradiction. That means no solution. You shouldn't be surprised. We've been talking no solutions, IMS, every day. So that's how you'll know. Okay? So the last section, I think there are 6 of them, maybe, or they're just 3. There's just 3, I took them out, okay? I want you to work through all of them. They might have one solution, they might have no solution, they might have IMS. We'll check those 3, we'll be all good. Use substitution. If there is a solution, please find it. If there's no solution, be ready to show me why not. If there's IMS, be ready to show me why. First one's IMS, they make it 6 equals 6. Yeah, if you plug it in, 6 equals 6, IMS.
Talk to me while I do this one. What? I have stocks invested. And then an entity.
Do you know that the 6th and the 5th one is a scale?
Yeah.
It is a scale. Which is it? Like, that's a good point. It's just a hard
First one's IMS. The third one is no solution. Second one, just in the interest of time, I actually use elimination instead because I felt like it. You do get 7 to the third, comma 0, but they just wanted to know if there was a solution there as well. Okay? Big thing to look out for. IMS means you get true statement, just like we've been doing for an extra while. No solution would look like a contradiction. It is NS, and then you kind of move on. Okay? So substitution is pretty critical. I know a lot of you like elimination. That's fine. I like elimination too. Substitution is going to come up quite a bit, and I know you can handle it because it's basically pre-algebra. You just have to plug in correctly, okay? Please take the last 10 minutes to start looking at this. You can actually get a little bit done, then finish it over
I
there.
ate all the chocolate shell.
No, we need complete focus for about 10 minutes. This table in particular.